Alright, so this week for lesson 18 for our group problems, we got the following answers. For number 3, it says use the data in table to find p hat 1. And so we know from the information that P1 will be the females, and that we're looking for those who can taste PTC. So that would be 52 out of 70, which comes to 0.743. Alright. And use the data to find P hat 2. So that would be the males, 42 out of 59, which comes to 0.712. For question 5, which set of hypotheses is appropriate for addressing the research question? That would be P1 equals P2 and P1 does not equal P2, because we're simply trying to determine if there is a difference, if they're independent or not. So create a 95% confidence interval for P1 minus P2. And so what is the point estimate? Well, our point estimate is P1 minus P2, which comes out to be 0.031. So they're pretty similar. And the margin of error for this, using our formula, we get 0.003.
For that one, really quick, what equation did you use?
So margin of error is your z square, or your z star, so what your margin of error you want to be. So in this case, 95 is 1.96, and then the square root of p hat times 1 minus p, divided by n. So it should look like this.
So p hat. Oh, okay. Okay.
Yeah.
Perfect. That makes more sense.
No problem. So the lower bound would be our total p-score of yeses. So the total yeses divided by the total minus our margin of error. And that gives us 0.726. And the upper bound would be just adding it instead, which would be 0.732. And then question 10 is, if our alpha is 0.05, what decision do we make? We fail to reject the null hypothesis, or A, because our score is much higher than that. Which of the following statements best describes the outcome of the study? And that would be D. There is insufficient evidence to suggest that the true proportion of females who can taste PTC is different than the true proportion of males who can. Or who can't. Or can, yeah, can. And that is because we failed to reject the null hypothesis, so it holds true. So question 12. As the conditions for conducting a hypothesis test are satisfied. And there's formulas you can do, but the really simple way is that there's 4 real conditions you have to find. And that's 10 expected, 10 failed for each group. And so these are really big numbers. So just looking at it, it's true. But if you run the numbers, you can also find the same thing. It just takes a little longer because the numbers are really big, so there's a lot of typing. So question 13, which set of hypotheses is appropriate for addressing the research question? Well, the research question says, is the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who die less than those who come in on the weekend and die? It's kind of sad, but that means that for our null hypothesis, they're equal, because we always assume that it is, and that means our P1, who is the weekdays, are less than our P2s. That's D. And use the data in the table to find P hat 1. And So we take those who died in group 1 divided by the total admitted, and we get 0.141. And use the data in the table to find p hat 2, which is the other data set, and we get 0.145. And our z-score is negative 2.020. And we find that z-score by doing this other formula that's really long. And that is p hat 1 minus p hat 2 minus p1 minus p2, which are the same. So it's 0. Divided by the square root of this long equation again of p hat times 1 minus p hat times 1 divided by n1 plus 1 divided by n2. And so we get negative 2.020. Question 17. Give the z-score from the last question. Which should you shade, left or right of the z-score? It's to the left because it's negative, and we're wanting to find what's less than that point. So, what is the p-value for this test? Well, if we go into our normal probability applet and type that in, then the area highlighted is 0.022, and that confirms our z-score, because our z-score is 2, is a little more than 2, so there wouldn't be that many above it. And so if our alpha is 0.05, 0.022 is less than that, so we reject the null hypothesis, which means that there is sufficient evidence to conclude that the proportion of patients who had a heart attack and were admitted to the hospital on a weekday who die is less than the proportion of patients who have a heart attack who are admitted on the weekend who die. And that is all for lesson 18. Oh. Computer's freaking out here. Well, I guess I'll submit that later. Okay. So Amber, did you want to do 19?
Yeah, I've got 19.
Okay.
Do we have to start a new video for it?
No, we're good.
No? Okay. I guess I'll start.
Yeah.
Okay, so for 19, question 3, which set of hypotheses is appropriate for addressing the research question? That'd be the third one. Null hypothesis, gender and voting purposes are independent. And then alternative hypothesis is gender and voting purposes are not independent. For 4, what is the equation for computing the degrees of freedom? And that would be the last one, number of rows minus 1 times the number of columns minus 1. So what is the correct choice for degrees of freedom for this problem? The answer would be 2. And for all this, I just put it into SPSS and then figured it out from that point. And then for 6, are the requirements for conducting sort of tests for independence met by this data set? Yes, there are at least 5 expected counts in each cell. 7, what is the value for the test statistic for this problem? So we just input into SPSS and follow the instructions. You should get 16.204. And then for 8, what is the value of p-value for this problem? And that would be 0. And then 9, which of the following statements best describes the outcome of the study? And it would be there is sufficient evidence to suggest that gender and voting preferences are not independent. And then for the next one, for 10 are the conditions for connecting test for independence are satisfied, and that's true. And then what are the degrees of freedom for this problem? That'd be 8. And then for 12, what is the value of the test statistic for this problem? And that'd be 7.436. And 13, what is the value of the p-value for this problem? And that would be 0.49. And then which of the following statements best describes the outcome of the study? That'd be B. There is insufficient evidence to suggest that motivation to visit a chiropractor is not independent of the location.
Those double negatives. Cool. Alright. Huh, that one worked.
Yeah, my first one didn't work either.
Yeah, that's weird. Oh, for question 9, I had E.
For 9,
Yeah.
E.
There is sufficient evidence to suggest that gender and voting purposes are independent. But that doesn't make any sense.
I've already turned it in.
Yeah. But that doesn't make any sense if our p-value is 0, right?
Yes, if our p-value is 0, we're going to reject it.
Right.
So,
So it should be C. But it's keyed in as E. Huh. Okay. Oh well, we'll talk to him about that, I guess. Alright, so for our group project, I just wanted to go over it again. So it's going to be a quantitative study. It's not categorical, even though we're trying to prove something is true or false. It's just easier if we do a numerical data. So I need to ask you guys, per pepperoni slice of pizza, how many pepperonis do you think should be on there normally for a medium-sized pepperoni pizza from Domino's?
3.
3?
Yeah, 3 or 4.
3 or 4? Okay. So we'll do 3. And for our randomization, in order to make it random, if we just count every single slice of pizza, then it's not random, you know? But if we do like every other slice of pizza in our whole pizza that we get, then it is random because then it's not every single one. And then we just compare it. Huh?
I just said, yeah, that sounds better.
Okay, so we'll do it that way then. And we'll do every other slice. Cool. So yeah, I'll get that sent in by tomorrow and send that to you guys. And barring any other weird hiccups, it should be fine. So we can start taking our data next week. And so between the 3 of us, we need to get 30 slices of pizza tested, which means if we're doing every other slice, it's 60, right? 60 slices total. So 60 divided by... There's what? 8 slices normally per pizza?
Yeah.
Okay. So equals... So that's 7.5 pizzas that we have to buy. So 8 pizzas. So if you both buy 2 pizzas, then I can get 4. And then if we each record every other piece of pizza, the number of pepperonis on it, then we should be good. It works out because, like,